Okay, we're recording. This video is made specifically for you, Kyle. I'd like to show where I'm at here, and just for the record, there's 3 different display options and 4 different drive options. Now this is the simplest one that you can make. In fact, it's oversimplified and has what I refer to as ghosting on the vertical axes when the negative rail's engaged. Just for the moment here, we'll drive a couple motors. There, forward, reverse, forward, reverse. There. That one forward, reverse. I'm going to put the camera in my hand here and try to hold it steady so you can see the display. See when the green rail's energized, you see ghosting there. You're getting a backfeeding from the drive matrix to the display. This is undesirable, but I cannot fix it with a single pole switch. I need 2 poles to isolate the display matrix from the drive matrix. And I tried to piggyback the switches like this on top, but the switch is rocking back and forth as it turned because it's not precisely built, and it's causing the servos to run tight in the gears. The only other way to overcome that is to use relay buffering on the axes, or to go back to a 2-pole 6-position switch, which then I can isolate the display. Here's a 2-pole 6 that I pre-wired, and that way we can isolate the display matrix from the drive matrix, thereby eliminate that ghosting. There you see the ghosting again. Wherever there's a motor hooked up on the vertical axes, you will get that ghosting, but only occurs when the negative rails are energized, because the drive matrix is backfeeding a negative voltage to the display. And I cannot eliminate that without having extra switch poles or using relays to isolate it. And there's the one I've made before. This one is being demonstrated already on YouTube. This is the one I ordered the parts a couple years ago. That's the one I made. These were meant to be relay buffered for the bigger machines up to like 10, 15, 20 amps, using a relay buffered multiplex drive or relay buffered conventional drive. This is what I refer to as direct drive, multiplex direct drive. It's the simplest form of the system. If you can accept the fact that the display matrix is having ghosting. Now, we make a simple one for the kids. If I go back to a 6x12, using the 2-pole on this vertical axis, we'll have 72 functions, and I can add a 3rd drive bank. So we'll have 18 motors and 3 banks of 6. I can re-engineer the system that way for the simpler beginner skill level or starter kit, and I've costed it out that way will be about $40. We'll only need 1 gear set because we'll use the 50-20 on the 12 switch and the 40-30 on the 6. And in that way we'll eliminate the ghosting problem and still be able to drive 18 motors instead in 3 banks of 6. And I'd like a little bit of feedback from you to let me know if the people can accept the fact that the display will ghost when the negative rails are energized, and we can go ahead with this one. Every system will have pros and cons. The pros of this system are the number of functions it can do and the simplicity. The cons, in this case, we have that little bit of ghosting in the display, and that is caused by a strenuous current flow from the drive matrix backfeeding the display, because I cannot isolate the display from the drive using only single pole switches. I tried to piggyback them like I said, but mechanically I'm getting some tightness in the gears because the thing wants to rock back and forth. If I try to mount it rigid, it's not perfectly aligned, the switches, when they were made, and it's causing the servos to run tight through the gear system, and that's not good. So I'd like a little bit of feedback. Let me know if we can redesign it as a 6x12 with 3 banks of 6 motors, or we can just accept the fact that the display is ghosting. And we'll offer it as a starter kit. This will be around $50 if I forego the display matrix, and we'll just use the 1 amp diodes instead, because each motor is driven from its own diode set, so each set of diodes only drives a single motor, and most little toy motors don't draw more than 1 amp of current, so we'll be fine. These switches can handle at least 3 amps at the lower voltage. I know that for certain because I've tested these switches to destruction and these diodes, and I know what they can handle. So I'd like you to, like I said, give me some feedback on that, and we'll design the system. Maybe this will be the starter kit, introductory kit, would only be about $40 or $50, and still is a very good system. And then if the people like it, then we can go with a more advanced system, or there's different ways we can make it work the way it's supposed to without ghosting. Thank you.